All right, greetings everyone. Welcome to the fifth part of the video for section 5.3. We're going to continue on building on this idea of reference angles and sines and cosines of angles based on their location on the unit circle. Now, I should mention that before watching this video or moving forward with the content in it, it's really important that you have either familiarized yourself with the unit circle or taken some time to watch the videos I've posted about the unit circle. Now, those videos may not be posted yet as you're watching this, but I promise they will be. Okay, so let's return to a problem that we did earlier in this section. So we were asked to find the sine of alpha, given that the cosine of alpha, and where alpha is some angle, equals 5/8. And when we did this, you may recall we used the Pythagorean identity. And once we worked everything out using the Pythagorean identity, what we found is that the sine of alpha here was equal to plus or minus, the square root of 39/8. And we pointed out that the sine of a particular angle cannot be plus or minus. It has to be one or the other. And so the question is, how do we determine which one that is? Well, this problem kind of gives us the answers to that because they're given two different conditions here. If alpha is in the first quadrant or alpha is in the fourth quadrant. So let's look at how that might be different. So if alpha is an angle in the first quadrant, so thinking about our ideas of angles being measured in standard position, we know that means we start here on the positive part of our horizontal axis, we rotate around counterclockwise, and we stay in the first quadrant here. And so this would be our angle alpha. And recall that on a circle, or the unit circle, right, the point where the terminal side of that angle meets the circle, so that point x comma y, on the unit circle, that is actually the same as the cosine of that angle followed by the sine of that angle. Okay, and I ran out of room there, but that second part should say sine of alpha. Now, because we're in the first quadrant there, what can we tell ourselves about the points x and y here in terms of their sines? Right, they should both be positive, right? Because we know all x values along here will be positive, all y values along here would be positive. So what that tells us is because the sine value comes from the y value, that it has to be positive. So in the case where alpha is in the first quadrant, we're going to have that sine of alpha is going to be positive root 39/8. Or we can just write that as root 39/8. Okay, so that's the first case. Now let's look at the second one where alpha would be in the fourth quadrant now. So what this means in terms of our picture, I'll redraw that here. So we'll again have our set of coordinate axes. We'll start here on the positive part of the horizontal axis. Now we're going to the fourth quadrant, so we're going to rotate all the way around to here. Okay, and this is where our terminal side would be. So this would be our angle alpha, this big angle here. And again, if I add in our unit circle here in blue, we once again know that this point where that terminal side intersects the circle, that x comma y, well, that's going to give us, for the angle alpha, that's going to give us cosine of alpha comma sine of alpha. And let's think about how things may or may not be different for the values of x and y here. Well, first of all, for the x values, we know we're still going to be along this part of the horizontal axis, so those x values will still be positive. But now we're going to be along this part of the vertical axis, which is going to make our y values negative. So that tells us the sine of the angle alpha in this case must be negative. So here we would have that sine of alpha is going to be negative root 39 over 8 in this case. Again, because we are in the fourth quadrant now. Okay. All right. Let's look at a couple more examples, and these ones now relate to the unit circle. Okay. And what we've got here are a couple of angles that do not appear on the unit circle. So if you look at your unit circle, you will not see negative pi over 4, nor will you see negative 240 degrees. But both of these angles are coterminal with angles that are on the unit circle, meaning that they share terminal sides with angles that are in the unit circle, which then means that their sines and cosines will be the same as those angles. So let me go ahead and draw that's sort of a unit circle there. And the first angle we have is negative pi over 4. And negative angle tells us we're going to rotate clockwise. And if you recall, pi over 4 is the same as 45 degrees, so it's like negative 45 degrees, so that's going to take us to right here. So the question is what angle on the unit circle will that be coterminal with? Well, first of all, notice that because this angle is pi over 4, or negative pi over 4, its reference angle there, to measure the angle back to the horizontal, would be pi over 4, or 45 degrees. So what we really need to think about is what angle on the unit circle that's in the fourth quadrant down there has a reference angle of pi over 4 or 45 degrees. And the answer we'll come up with there is 315 degrees, or 7 pi over 4. And we can double check that because we know that this angle right here is 360 degrees, or 2 pi. And if you take pi over 4 away from that, subtract that to get back to here, we'll get to 315 degrees, or 7 pi over 4. And when we look at our unit circle for the cosine and the sine there, we'll see that the x value, or the cosine, is root 2 over 2. And the y value is going to be, or the sine, will be negative root 2 over 2. Again, because we're in the fourth quadrant. So what that tells us then is that the sine of negative pi over 4 is going to be negative root 2 over 2. And again, the reason for that is because it's going to be the same as the sine for 315 degrees, or 7 pi over 4 radians. Okay? All right, let's look at the next one now. So now we have cosine of negative 240 degrees, which means now we're dealing with an angle that we're again getting from rotating counterclockwise, but this time, or excuse me, clockwise. This time we're going negative 240 degrees. So let's see how far will that be. Well, this is negative 90, negative 180, and then if we go negative 60 more degrees, then we'll be at negative 240 degrees there. So we end up in the second quadrant. Now, just like in the last one, to figure out which angle this is coterminal with on the unit circle, let's first find the reference angle here. So this pink angle, which I believe, if you recall, as I was going around, I said that this was negative 180 degrees. So to get to negative 240, we had to go 60 more. This looks like our reference angle here is 60 degrees. Which, if we think about what's the angle on the second quadrant, on the unit circle that has a reference angle of 60 degrees, well, that would be 120 degrees, or 2 pi over 3, right? Which we can think about, because we know on the unit circle, this angle here is actually positive 180 degrees. If we take 60 away, we end up at 120 degrees. And there are the coordinates, the x and y value there. So for the cosine, we would have negative 1/2 since we're in the second quadrant. And then for the sine, we'll have root 3 over 2. And sorry, I'm just thinking, make sure I did that right. Okay. And so then that tells us that because we're looking for the cosine of negative 240 degrees, so that's going to be the same as the cosine for 120 degrees. Should be the x value there, which in this case gives us negative 1/2. Okay. All right. That's all we got for now. Thank you for watching.